Generally, what you have are three categories. A compound will either be a type 1, a type 2, or a type 3. Type 2 or type 3. Now, when you determine which type of compound takes, you have to know something about the compound. Type 1. These are ionic compounds. And you know it's ionic because it has a metal. Okay? Ionic compounds always have a metal or NH4 plus in the formula. If it has no metals, it's not ionic. Okay? So type 1s are ionic compounds, and their metals.
What's NH4 plus?
Ammonium. Okay? It's one of those polyatomic ions, except it's a cation.
Ammonia.
Ammonium. Ammonia is NH3. Okay? Ammonium is NH4 plus. Okay? But type 1 are metals with fixed charge. So the metal in these formulas, you know their oxidation state, you know their charge. And so if you look at the periodic table, we just talked about this a moment ago, and you look at chemicals in 1A, what are the oxidation state or what are the charge of the elements in the 1A family? Sodium, lithium, potassium? Plus 1, exactly. Because they have one valence electron, and it's easy for them to get rid of that one valence electron to get an octet or a noble gas electron configuration. So they're all plus 1. 1A is always plus 1. Elements in 2A are always what?
Plus 2.
Plus 2, exactly. Okay? The transition metals, you don't know. They're not a type 1 compound because you don't know their charge. They can give up 2, they can give up 3, sometimes they can give up 7. Okay, you don't know. But the other elements that you do know are aluminum. What do you think aluminum is? What family is it in?
3.
So what do you think the charge is?
Plus 3.
Plus 3. That has a fixed charge. And then the transition metals that do have an exception are these right here. These right here are zinc, cadmium, and silver. Zinc is always plus 2. Cadmium is always plus 2. And silver is always plus 1.
Is it silver or Ag? Mercury.
Silver, Ag, always positive 1. Okay? So if you have any of these metals in the chemical formula, it's a type 1 compound.
Okay.
Okay? Just know that if it's not group 1, it's not group 2, it's not aluminum, zinc, cadmium, or silver, then it's got to be the other type. So this is important, okay? Because when it comes to the rules of naming, type 1 has a different format than type 2. Okay? So what is a type 2 element? Type 2 elements are metals that are not type 1.
Were you saying just aluminum or that whole group?
No, just aluminum.
Just aluminum.
Just aluminum.
Oh, okay.
Aluminum, cadmium, zinc, and silver. Those are the 4 other than group 1 and group 2. So type 2.
Aluminum's a plus 3.
What was that? Yeah, aluminum's plus 3. Type 2 are ionic compounds again. How do you know it's ionic? Because it has a metal or NH4 plus. That's how you know it's ionic. With variable charge. How do you know it's a variable charge? Because it's not group 1, it's not group 2, it's not aluminum, zinc, cadmium, or silver. Okay?
It's not group 2. Oh, group 2.
Yeah.
With variable charge?
It's a variable charge. That is,
So
it gives up 2, it gives up 3, it gives up X number of electrons. That's what I mean by variable charge. Okay? So now you can take any element and tell me whether it's a type 1 or a type 2. If I give you an example like MgCO3, is that a type 1 or a type 2 compound?
Type 2.
Find Mg in the
Oh, no,
periodic
type
table.
1.
Type 1.
Type
Because what is the charge of magnesium?
Plus two.
Plus 2. It's fixed, right?
Right.
Okay. How about if I told you AuN3? No, A3N. What would that be? Type 1 or type 2?
Type two.
Type 2. Because
AU is very.
AU is gold, and it's not in that list that we just mentioned. Okay? Now, the last category is type 3. And type 3 is easy because type 3 has no metals.
All the gases?
Non-metals.
No, oh, just non-metals.
Yeah, non-metals. Carbon dioxide is type 3. P4O10 is type 3. SO2 is type 3. None of these elements in here are metals. Okay? So, if we go back to this chart right here, this is the flow scheme that will help you determine whether you have a type 1, a type 2, or type 3. The first thing you want to do is look at the chemical formula, and you can tell that I made this chart back when Jerry McGuire was here, because you need to show me the metal. Okay? Because if there is a metal, it's either type 1 or type 2. And if the metal is group 1, group 2, aluminum, zinc, cadmium, or silver, yes, then it's a type 1. But if it's not, then it's a type 2. And then if you don't see any metal, that's type 3.
Okay.
Okay? Now that you understand that, the rules are easier. Okay? Let me tell you the rules. Because
Non-metals, all the ones in yellow.
all the ones in the yellow.
Not
Exactly.
What are metalloids? Are they?
Metalloids could be either or.
Okay.
So what is metalloids? That
Metalloids generally,
so only the yellow one.
only the yellow.
Only the yellow are your type 3.
Or your type 3, exactly. Okay? For allied health majors, you generally don't go to those sophisticated elements, so don't worry too much about those. But generally, if it's yellow elements in the periodic table, those are nonmetals. Type 1, how do you name it? You name it based on the metal first, and then the nonmetal. Or the metal, or the cation, followed by the anion.
This is naming, right?
This is naming.
So naming type 1, you go by the metal.
The metal or the cation, and then the anion, or the nonmetal, or the polyatomic ion. Okay? So if I give you an example like K2S, okay? Or if I give you another example like CA3N2, or if I give you another example like ALNO3, or I give you another example like ZNF2, or another example like CDSO3, okay? How would we name this? And the first thing that you want to look at is that all of these contains metal. So it's either a type 1 or a type 2. All of these are either group 1, group 2, aluminum, zinc, cadmium, or silver. So all of these are examples of type 1 compound. Okay? How do I name this, therefore? K is what element?
K is potassium.
Potassium.
Potassium sulfur.
And what's sulfur? It's sulfur, right? Except when it's an anion, you put "ide," so it's sulfide. That's it. Potassium sulfide. You don't have to do a per or anything. You just name the elements that make up that chemical. It's potassium sulfide. How about this guy?
Calcium.
Calcium,
Night.
Tri, not ite. Ide.
Ide.
And the reason why it's ide, it's an element. It's an element. It's an anionic element.
Oh, because there's no superscript on it.
No, there's no other
oxygen.
element. There's only one element. There's no oxygen.
That's what I don't understand.
See, these are elemental ions. N-3, S-2, O-2. These are polyatomic ions. NO3 minus, NO2 minus, CN minus, OH minus. You see how they have two different elements in their formula?
Yeah.
Those are polyatomic. These guys will generally not have IDE. This is oxide, this is sulfide, this is nitride. This is chloride, this is bromide, this is fluoride. So when you name these things, you always give it an IDE suffix because these are elemental anions.
Because there's only one element.
There's only one element for that.
There's not two elements together.
Yeah, this is not K2SO4,
Okay.
okay? It's elemental in nature.
If it's a polyatomic, what's the ending?
It's going to be one of those.
It depends on what polyatomic you have. If it's SO4, it's sulfate. You have to identify that.
But it's
polyatomic.
ATE always?
No, you have to recognize this guy right here.
Right.
Depending on what you have to find out what that chemical identity is. Okay? That's why it's important to understand the aids and
yeah.
break it down from there. So, going back over here, calcium nitride. What's that? Aluminum?
Nitride. I mean, no, those, it's
But
got an
it's-
oxygen on it. So
It's got oxygen, but what's an NO3? If you have a list,
Nitric
and this is
oxide.
found in the table, then
Oxide.
you could use it. It's called what?
Nitric
It's
oxide.
nitrate.
Nitrate. It's
So what's
nitrate.
the 3 on the end?
That's the chemical formula.
What's
Don't
the
worry
O?
about that yet.
Okay.
Okay? I just put that there because it has to be
Has to
electrically
be there, but
neutral.
you'll get to that.
Why
Yeah.
is there an
Okay.
O there?
That's the oxygen.
That's
How come you don't
because
say it in the name though?
That's what nitrate is.
that's what nitrate is. And nitrate,
If you look
Oh, I'm sorry.
Is
Okay.
NO3 minus.
That's a small O.
at, well, it says that
No,
on
it's
table 5.
it's an oxygen. It's not a small O. It's NO3.
So that's a
Right.
great.
NO
You have to
nitrogen,
memorize
oxygen,
these.
3 times.
Come up
But
with
how come the name doesn't have oxygen in the name?
Right.
Because NO3 is its name.
Well, how do you say it?
Nitrate is its name.
Nitrate.
It's nitrate. You don't say nitro oxide.
Oh.
It's page 160.
You don't, because it's a polyatomic ion. It's an entity that's stable.
Is that coming from like on page 160 to
Uh-huh.
5.8? It says you're not going to be able to find this. You
Memorize
have to
it.
memorize.
Yeah.
But we're going to
Because
have the
that's-
book on the test.
You have
so
the book and the test, right?
Okay.
And you
what I'm
get
saying is that's why you wouldn't know what that is until you knew.
right, exactly. You have to know the polyatomic
Right.
ions.
Yeah.
So that's an important page to know
Okay.
because that gives you a lot of the polyatomic ions that you will
Oh,
be
yeah.
using.
Okay.
Okay. So that is Al is aluminum, NO3 is nitrate, and you
Okay.
just name it aluminum nitrate.
Okay.
Okay. How about this guy? What would that be?
Zinc.
Zinc, ferro.
Zinc,
Laura.
fluoride. Zinc fluoride. That's just it. Zinc fluoride. How about this guy?
Cadmium.
Cadmium.
Um,
What's SO3?
sulfite.
Exactly. Sulfide. Cadmium sulfide. You notice I just say the metal and then the anion. Zinc fluoride, aluminum nitrate, cadmium nitride. I just name the elements that make up that chemical. That's type 1. Okay? Type 1 is you name the metal or the cation followed by the non-metal or the anion. And if it's elemental, then you give it an IDE ending. If it's polyatomic, you name the polyatomic ion. Okay? And that's summarized. If you want to review these rules right here. Summarize right here.